Dear students, last class we have discussed about the open cycle gas turbine with intercooler and also reheater. With these two, we can improve the network done, at the same time the thermal efficiency decreasing. So in this video, I am going to solve one problem regarding the intercooler as well as the reheater. So first I will read the problem. In a closed cycle gas turbine, there is two there is two-stage compressor. Here it is two-stage compressor means there will be two compressors. Compressor number one, compressor number two. So this is called the low pressure compressor and this is the high pressure compressor. So this is the intercooler is provided between the two compressors and a two-stage turbine. So two-stage turbine means there will be two turbines. So first turbine is the HP turbine and second turbine is the low pressure turbine. The pressure and temperature at inlet of first compressor are 1.5 bar and 20 degrees centigrade. So the air enters the first compressor at a pressure of 1.5 bar and temperature of 20 degrees centigrade. The maximum temperature and pressure are 750 degrees centigrade and 6 bar. So where we get the maximum temperature and pressure. So here the air enters first compressor at 1.5 bar and 20 degrees centigrade. After it is compressed, the pressure will be increased. This pressure is called the T2 pressure. It is intermediate pressure. So that its temperature also increases, T2. That is T2 dash. At pressure T2 and T2 dash, it enters the intercooler, where the temperature will be decreased. So to the T3, such that T3 is equal to T1, initial temperature. So it is mentioned that the intercooler is perfect. The intercooler is perfect means the temperature decreased, that is T3, it must be equal to T1. So the intercooling takes place at constant pressure. So at pressure P3 that is equal to P2 and temperature T3 that is equal to T1 enters the compressor 2. So where it is compressed to the final pressure. So which is the final pressure? It is the P4. P4 final pressure is given 6 bar. So that, and also after compression the temperature also increases. So with the temperature that is T4 dash and pressure P4 that is 6 bar, it enters the combustion chamber 1 where the combustion takes place by burning the fuel. So that its temperature will be increased, that is equal to T5. This is the maximum temperature, that is 750 degrees centigrade. But the combustion takes place at constant pressure, that is 6 bar. At 6 bar and 750 degrees centigrade, the gases will expand in the HP turbine. To what pressure it will expand? It is intermediate pressure. Intermediate pressure I have already explained, that can be calculated is equal to intermediate pressure is square root of initial pressure and final pressure. Initial pressure is 1.5 bar and final pressure is 6 bar. So 1.5 into 6 of square root, it is 3 bar. So that is here the gases will expand from 6 bar to the pressure 3 bar. So that the temperature also decreases from 750 degrees centigrade to T60 degrees centigrade, that we have to calculate. So at T6 dash temperature and the pressure of 3 bar, the gases will enter the combustion chamber 2 where the combustion takes place by burning the fuel, so that heat is supplied. Hence, the temperature will be increased. That is T7. T7, it must be equal to T5. So it means the entry temperature of the gases to both the turbines must be same. So T5 is 750 degrees centigrade and hence T7 it is also 750 degrees centigrade. At pressure of 3 bar and temperature of 750 degrees centigrade, the gases will expand in LP turbine to the pressure of 1 bar and temperature of T8 dash. T8 dash. This value must be calculated. So now, here I will explain the T8 diagram. At and pressure, temperature and pressure of temperature of 20 degree, sorry, temperature of 20 degree centigrade and the pressure of 1.5 bar, the air enters the compressor 1 where it is compressed to the intermediate pressure P2, so that its temperature increases, that is T2 dash. So at T2 dash and the intermediate pressure we have already calculated, it is 3 bar. It is enters the intercooler, so that its temperature will be decreased to the T3 such that T3 is equal to T1. So that the temperature is decreased such that T3 is equal to T1. So at pressure T3, that is P2, P2 is equal to P3, and temperature T3, that is equal to T1, will enter the compressor number 2, where it is again compressed to the pressure P4. P4 is nothing but 6 bar, so that its temperature will be increased to T4 dash. So at P6 bar and T4 dash, this value must be calculated. So the at 6 bar and T4 dash, the air, it goes to combustion chamber 1 where the heat supplied by burning the fuel, so that its temperature will be increased, but pressure remains constant. So the temperature is the T5. This is the maximum temperature. It is given 750 degrees centigrade. So at 750 degrees centigrade temperature and pressure 6 bar, the gases will expand in the first turbine. So that is HP turbine. So to what pressure it will be? P6. P5 to P6. P6 is nothing but intermediate pressure, that is 3 bar. So the temperature will be decreased, that is T6 dash. This we have to calculate all these values. At T6 dash temperature and pressure of 3 bar, that is intermediate pressure, so the gases will enter the second compressor, so that its temperature will be increased to the T7, such that T7 must be equal to T5. At T7 temperature, 750 degrees centigrade, and the pressure of 3 bar, the gases will expand in the LP turbine to the what pressure it is? P8. P8 is nothing but P1, 1.5 bar, and temperature will decrease from T7 to T8 dash. So these values must be calculated. Here I have written here. So P1 is 1.5 bar and T1 is equal to 20 plus 273, it is 293 Kelvin. T5 is equal to T7, that is given 750 plus 270, 1023 Kelvin. Final pressure P4, 6 bar. Isentropic efficiency of turbine and compressor both are given 0.82. Gamma is equal to 1.4. So I have already explained how the intermediate pressure can be calculated. That is, P2 is the intermediate pressure. It is equal to square root of initial pressure P1 and final pressure P4. So P1 is 1.5 bar, P4 is 6 bar. If you multiply it, you will multiply and take the square root, it will be 3 bar. So first we find out the T2. We know that T2 by T1 is equal to P2 by P1 over to the power of gamma minus 1. So all the values, if we substitute, T2 is equal to 357 Kelvin. So now we have to calculate the T2 dash. So efficiency of the compressor is equal to T2 minus T1 divided by T2 dash minus T1. By substituting all the values, T2 dash is equal to 371 Kelvin. So here T3 is equal to, after intercooler, T3 is equal to T1, that is equal to 293 Kelvin. So in the second compressor, we have to find out the T4. T4 by T3 is equal to P4 by P3 over to the power of gamma minus 1 divided by gamma. So T4 is equal to, if we substitute all the values, P4 is given 6 bar and P3 is given uh, 3 3 bar. So 357.24 Kelvin. Again, by taking the efficiency of the compressor, by putting the values of these values, we can easily calculate the T4 dash, that is equal to 371 Kelvin. Now come to the first turbine. It is T5 by T6 is equal to T5 by T6 over the power of gamma minus 1 divided by gamma. We have to find out the T6 values because T5 is known. So T6 is equal to 839 Kelvin. And by taking the turbine efficiency and putting all these values, we obtain the T6 dash 872.12 Kelvin. Now the second compressor, it is T7, we know that it is equal to T5, that is 1020 Kelvin. So T7 divided by T8 is equal to P7 by T8 whole to the power of gamma minus 1 divided by gamma. So this value T8 we have obtained is 839 Kelvin. So by putting again the turbine efficiency formula, so we obtain T8 dash, that is equal to 872.12 Kelvin. Now you know that turbine work is equal to Cp into, there are two turbines, that is T5 minus T6 dash plus T7 minus T8 dash. All the values are substituted and obtain 303.26 kilojoules per kg. And here compressor work, there are two compressors. So Cp into T2 dash minus T1 plus T4 dash minus T3. Substituting all the values, we obtain compressor work is 156.78 kJ kilojoules per kg. So W net is equal to turbine work minus compressor work. So this is the turbine work and this is the compressor work. Obtained 146.48 kilojoules per kg. Heat supplied. There are two combustion chambers. Cp into in first combustion T5 minus T4 dash plus second combustion chamber T7 minus T6 dash. Substitute the values, we obtain 503.62 kilojoules per kg. So thermal efficiency is equal to W net divided by heat supplied. This is substitute the values, we obtain 29%. So I hope you have understood. Thank you.